You can show how your eye sees objects located at different distances away from you using a lens made of gelatin. The materials you'll need are a ray box, a slit plate with 3 slits, a piece of paper, a marker, a piece of plastic transparency, some scissors, some tape, a small flat bottom dish, some gelatin powder, and some boiling water. To make the gelatin lens, cut 2 rectangular strips of transparency that are about 1 centimeter by 6 centimeters. Next, tape them together at the short ends. This is the mold for the lens. If you don't have plastic transparencies, you can cut other flexible materials, such as strips from a milk carton. To make the lens, pour gelatin powder into the dish and add boiling water to create a gelatin solution. Around 1 tablespoon of powder per 50 ml of water is good, but follow the instructions on your packet of gelatin powder. The mixture should be roughly 1.5 centimeters deep. Place your mold in the dish and put the bowl in a fridge for about an hour or so until the gelatin sets. Once the gelatin is set, slowly remove the mold from the dish. Next, slowly separate the lens from the mold and set the lens aside. The lens can tear, so take your time and separate it bit by bit. I added a stick to help keep the mold in shape. It's a good idea to make a spare lens, just in case your first one breaks. To do the activity, put the paper on a table and place the ray box and the lens on top of it, placing them next to each other. Make sure that the rays coming out of the ray box are diverging and not parallel. The rays should converge on the other side of the lens. Dim the lights to make them easier to see. Now move the ray box away from the lens until you can just clearly see where the rays converge. Mark this spot by drawing an X on the paper. Draw a circle with the X on one side and the lens on the other side. It represents the eyeball. The whole setup is a 2D model of the eye clearly seeing a distant object. Next, move the ray box closer to the lens until it's a few centimeters in front of it. The rays now converge beyond the X. This represents the eye seeing a blurry image of a nearby object. Finally, carefully squeeze the lens until the rays converge at the X again. This models how muscles in the eye contract to change the shape of the eye's lens, a process called accommodation, until the